Pro Communications and Security Systems. The purpose of this video is to demonstrate a Cel-Fi repeater that has a hard-coded 5 GHz link channel versus a non-5 GHz link channel. So what we're demonstrating here is a Telstra repeater. So this is the coverage unit, that's the window unit, and we've actually hard-coded a 5 GHz link channel between the two units, and just demonstrating how stable it is. So at the moment, if I grab the coverage unit, usually if I shake that around on a hard-coded 5 GHz channel, you would lose a signal. So I'll just shake it again. Okay, very, very stable. So I'll keep shaking it. As long as the power socket doesn't drop out, as you can see, it does not drop whatsoever. Now I'm going to plug in the Optus unit and you'll see the difference. I'm just going to pause this for a minute. Okay, so now I've just replaced it with the Optus repeater. So Optus and Vodafone apparently use the same repeater model, which is the RS218, versus the Telstra one, which is an RS250. The reason why the Telstra one's called an RS250 is because it has different antennas in there to cover the 850 megs, versus Optus and Vodafone, which use the 900 meg band and the 2100 meg band. So we'll just wait for these repeater pairs, or the repeater pair, to sync, and then we'll see what happens. Okay, so the repeater has synced, so we've actually got a link between the two. Now I'll grab this and give it a shake. Look at that, it's already dropped. So that's been a problem with most of the Cel-Fi repeaters, is if you do that, obviously it's going to drop. But the reason why I shake it is really just to establish that the signal fluctuates, and any sort of signal fluctuations that can occur in, for example, car park basements and where there's a bit of people traffic. So what actually happens, the repeaters can lose a signal because of the signal fluctuations, and it causes the coverage unit to lose the repeater pair to lose its link, and then the coverage unit displays the searching function again. So it's trying to re-establish a link. During this transition, the repeater doesn't repeat the mobile phone signal anymore, and so there's a loss of coverage until that re-establishes the link. So hard coding the channels reduces that and this problem, and basically increases reliability. So I'm going to plug the Telstra repeater pair back in again and just demonstrate the benefit of hard coding. So I'm just plugging the Telstra repeaters back in. Okay, just plug the coverage unit back on. So as you can see, it's starting to sync again, which is normal. And then we should get that link re-established. It's interesting to see how long the units will take to link back to each other. I'll just confirm that they actually are the same repeaters, a matching pair, and that's by reading the serial numbers at the back, in which they are. Okay, we have the link established. Now I'm going to disconnect the power to the unit, just to see what happens. There we go, I've disconnected the power. I'm going to plug it back in. So it linked up pretty quick. So we're going to drop the power again. And switch it back on. See, it's pulsing. And what we're finding now, the re-establish link up time is much faster. Give that a shake, no problem. So what's the benefit of hard coding? The benefit is that the dropout time is a lot shorter, so if there are any sort of interference issues, then that link will re-establish itself much quicker. In situations where we're installing, say, two or more repeaters, so to cover Vodafone and Optus, hard coding, we can actually set each channel or hard code each channel into the repeaters, so therefore the repeaters aren't going to be wasting too much time trying to find its own best working channels. And the other benefit is if you're using more than 3 repeaters, so we're using stacks of repeaters, so we're setting up say three networks, so 3 repeaters, and then we're using another set of 3 for the other 3, you know, repeating the other 3 networks, then we can actually hard code by using, say for example, channel numbers of 1, 3 and 5 for one repeater pair, and then we can go evens 2, 4 and 6. So and that would actually help maximize in some cases the channel capacity, and also we're working on capture effect, so we're using distance or separation between repeater pairs in stacks of 3, and then we use say evens for one set of 3, and we can use the odds for the other set of 3 to increase the capture effect. Or we can stick to 1, 3 and 5 and then stack and also work on capture effect between the 3 repeaters, and then it just reduces dropout time. So the benefit of hard coding in essence is basically increasing reliability. And then when we add these to our Cel-Fi enhancers, Cel-Fi enhancers basically is the RF enclosure with our filters and so forth, which goes over the window unit, which then has enables us to externally antenna or cable to the window unit, and we keep these in close proximity. Is we work on capture effect on the 5 GHz link. We hard code the channels to keep the system stable, and then basically we have a more reliable and stable repeater network in multi-dwelling units, car park basements, or industrial or commercial other types of sites where the interference impact may be greater. Thanks for watching this video from Pro Eye Communications and Security Systems.